Hi.
Alright, let's see. Good. Give me 1 second. Let me give you the link. Alright, did you get the email with what we're gonna cover today?
Oh, yeah.
Okay. Did she give you the 2012 test? What we're gonna cover today?
2012. Yes.
Okay.
Oh, hold on. Hold on. Hold on. Let me check my email real quick. Yep. Got it.
Okay. Alright, so okay, do you wanna go over the multiple choice questions because there's some good multiple choice questions, or do
Okay,
you want
sure.
to go to the FRQ stuff?
Yeah, let's go over multiple choice question first.
Okay. Did you get a chance to do it or no?
Hold on. No. You
No?
mean the multiple choice?
Okay, but you have it, right? It's a 2012
Yes,
public
yes.
practice exam?
Yep.
Okay. Alright, so it's our I also brought it up on the live stream. Uh you can do it on the live stream if you want. We're just gonna go one by one and we'll just talk about it, okay? You
Mm-hmm.
give me your answer and give me an explanation, then we'll go from there, okay?
Mm-hmm.
Alright, let's start with number one. Give me the answer with your explanation.
B,
Why do you say B?
because like the mean is around 5 and uh like the average distance between the value and the mean is the greatest in B.
Okay, there is no representation of the mean though in number one.
Uh,
Your answer is correct, but there is no mean of value 5 in here. They all have different they all have different means here.
what? Uh, but
So,
the graph is symmetric.
yes, but okay, so your answer of saying that the mean is around 5 and that as it's far apart from 5, correct? That's
Mm-hmm.
why you're saying it has the largest standard deviation. That's that is partly you're 80% there. The part that you're missing is understanding that the standard deviation has to do something with like gaps or distance between each point. So if you
Ah.
look at just the size of the gap, right?
Mm-hmm.
B has the largest gap between the
Mm-hmm.
points. Does that make sense?
Yes.
Like ignoring the value of the mean because right 0 and
Okay.
5, right? Because you can't really say, right, because the points are at different values, so you can't really get to the mean value of 5.
Mm-hmm.
Okay, so
Mm-hmm.
the standard deviation is referred to the distance between um, each data point, right? This one has the largest distance basically. Okay,
Mm-hmm.
all right.
Mm-hmm.
Number two.
I'll say 16.
Okay, how'd you get 16?
Q3 minus Q1. Q3 is 20 and Q1 is about 5 or 4.
Okay, why can't it not be D? Why can't it not be D or E?
Uh, I mean, it is not because IQR is like the body part of the box.
What's the definition of the interquartile range? Visually, what is the definition of the interquartile range? It is the size of the what?
It is the size of the
Box,
yeah.
right? And it makes no sense because the box here is only spanning a very short distance, right? That's what I'm trying to get you to say. because
Mm-hmm.
you're giving me the great calculation, so that's good. Before we move on, I'm going to throw in a side question. What percentage of the data exists in the interquartile range?
50% of the data.
All right, good. Okay. Number three.
Number three. I'll say it's skewed to the left.
Okay, that's correct. Most of the
Mhm.
data is clustered to the right. Okay, so
Yeah,
it's
so
skew
yeah,
left.
yeah.
Good. All right. Number four. A bank survey of its 60 employees to determine the proportion who participate in volunteering activities. Which of the statement is true?
Uh,
Let's go. Okay. A. The bank should not use the data from this survey because this is an observational study. True or
no,
false? Okay.
so
B. The bank can use the results of this survey to prove that working for the bank causes employees to participate in volunteering activities.
no.
Okay. C. The bank did not select a random sample of employees, so the survey would not provide the bank with useful information.
Maybe.
It only has to be random if you're going to run an experiment or an inference test, but there's no inference test involved in number four,
I mean, what is inference test?
like your hypothesis testing, your child square, your things like that.
Mm-hmm.
Okay, they didn't have to do anything. They're not trying to prove anything. Okay, so
Mm.
you don't. It doesn't have to be random. D, the bank would have to use the survey data to construct a confidence interval in order to estimate the proportion of employees who participate in volunteering activities.
So does this 60 does like uh is this 60 employee? I mean,
I'm waiting for your question.
oh, no, because it actually is like a census.
Yes, it's part yes, but also understand that the bank is surveying. They're no, the bank isn't trying to like come up with a is they're not trying to prove anything or identify anything,
Oh yeah,
right?
true. Yeah.
So the only thing you're left with is E. There's no inference. So look at the part right here on part B. The bank does not need to use any inference procedure. That is basically like a confidence interval, chi-square test, any of the uh, testing measurements that we do, right? To
Mm-hmm.
determine the portion of employees who participate in volunteering activities because they were just surveying right?
Mm-hmm.
When you survey, you're not trying to like
Yeah, yeah.
determine if something is different or not. Okay,
Yeah.
it would be
Yeah.
different if they're trying to say, well, the bank randomly selected 6 employees to determine if working for the bank, has them volunteering more or not. Okay,
Mm.
that would be
Mm.
different. But here it's just surveying. Okay.
Mm-hmm.
All right. 5.
5. It's I'll say it's 6.25.
What? What answer? Well, you're gonna say B because
Yeah.
that's the
B.
closest to your 6.25.
612. Why is 6125?
No, no, you're saying 6.25, so you're saying B, right?
No,
7.25 is the closest for 5.
I said 7.25.
Oh, 7.25, yeah.
Okay.
So how did you get that?
So you divided the population by 2, so
Okay, and that should be
87.5.
yes, so 87, yeah, well, yeah, 87.5 is where the median should be. So
Yeah.
how did you use the median to figure out the answer?
Like there are 80 people from 0 to 5
Mhm.
and around 50ish people from 5 to 10. So
Mhm.
the median have to be is this in this interval.
Correct. Good. All right. It's the area on the curve. Good job. All right. 6. Data was collected on the amount in dollars that the individual customer spent on dinner in an Italian restaurant. The quartiles are given. Which of the following is true given the quartile information? What are you thinking, Kevin?
Hold on. 25% of customers. Um, I'll say it's A.
Correct. All right. Quartile 2 is another name for the median. So half of the data is to the left, which is the language of spend less than 40.
Yeah, but the wording here is interesting. It says at least half.
At least half. So you're because it's saying it doesn't have to, it can be the value of 44.27 or less than 42.27.
Okay.
So
Oh,
what's your
maybe there will
concern?
be. Okay, I understand. Maybe there will be multiple value of 44.27. Yeah, I understand. Okay, let's move on.
Okay, what about B? No, okay. So what's the correct way of saying B? 75% of the customers spend between what?
Spent greater than 36 or less than 85. 58.
Shouldn't it just be less than 57? No, shouldn't it just be less than 58.97? Why are you saying in between?
I didn't say between.
Okay. Still
I
some
said either greater than the Q1 or less than Q3.
Okay. Good. The median. Okay. All right. Or wait, are you allowed to say E? A majority of the customers spend 44.27.
No,
Why?
maybe, I mean, you don't know.
What is the majority refer to? Oh,
At least half of the population.
the majority is sometimes used to describe the what? Mean, medium, or mode.
Mode.
All right. Okay.
Yeah.
7. You will
Oh,
actually have to calculate this out.
I mean, 7 is upside down. What the heck?
Hmm?
7 is upside down here. What?
It's not upside down.
Okay, it is here now. Alright. The weight of a Delma grizzly. Where's my calculator?
As you are working on it, I can read it out. The weight of an adult male grizzly bear lives in the wild in the United States is a normal distribution with a mean of 500 pounds and a standard deviation of 50 pounds. The weight of an adult female bear is approximately a normal distribution with a mean of 300 pounds and a standard deviation of 40 pounds. Approximately what would be the weight of the female grizzly with the same standardized score, z-score, as the
I'll say
male
it's
bear?
B.
You got B? Okay.
B. B.
How did you get B? What did you have to calculate first?
Z score?
The z-score of using what?
Z score of the male grizzly bear?
Correct. And you got the value of
0.6.
0.6, and you plug that in into the one with the female and solve for x, which is
Yes.
324 pounds. Good?
Yeah, yeah.
All right. 8, 8. A company sells concrete in batches of 5 cubic yards. The probability distribution of x, the number of cube yards sold in a single order for concrete for this company, is shown in this table. The expected value of the probability distribution of x is 19.25 and the standard deviation is 5.76. There is a fixed cost to deliver the concrete. The profit y is in dollars. For a particular order can be described by that equation. What is the standard deviation of y? So what is the standard deviation of the profit?
$432.
How did you get 432?
You times the standard deviation of x with the slope.
Okay, why aren't you subtracting the 100?
Because adding or subtracting does not change its shape.
Correct. Good.
I mean, change its spread, or yeah.
Correct. When you're just dealing with the standard deviation, uh, the idea of anything that is fixed does not affect that. Okay?
Mm-hmm.
Alright, good job. Alright. And 9. Go ahead. Based on the survey of random sampling 900 adults in the United States, a journalist report that 60% of the adults in the United States are in favor of increasing the minimum hour wage. If the report percentage has a majority of error of 2.7 percent points, what is the closest to the level of confidence?
Level of confidence. Margin of error of 2.7.
Mhm.
If the percentage has a margin of error.
Do you know how to use the margin of error?
I know.
Okay.
But maybe my calculation is incorrect. I don't know.
What are you calculating?
Finding the standard deviation. It's square root of 0.6 times 0.4 over 900.
Okay.
right? And this score times the standard deviation equals to 0. Oh, that's why. God. Um, is it 90%?
Why? How did you get 90%? What was your Z star value?
1.65.
All right, 1.65 is close to what percentage value? If you look at it in the chart, it is at what? 90, correct?
Yeah, yeah.
hmm Also, if you remember your empirical rule, right? One standard deviation is at what is the Z star for one standard deviation? Do you remember?
Oh,
One
wait.
one standard deviation is the 1.645.
1.645.
Yeah, the
This is
empirical
one
rule.
standard.
Remember the empirical rule,
Oh,
right?
68, 95, 99.
Yeah. This is 90. This is 90, the one standard deviation.
Okay.
Right? So that's another way of doing it without having to do like the looking up in the chart.
Mm-hmm.
Okay?
Do we have to know the empirical rule
Yeah. Well,
like
it's
this?
because you can always because there's the chart that's always given, and you could
Mm,
always do like inverse norm. But for me, I like it's just something very useful because you
Okay.
see like where 1.645, 1.96
Okay.
always
Yeah.
appears. Okay?
Mm-hmm.
It makes doing the z-score stuff easier if you have those memorized. Okay?
Mm-hmm.
All right. Let's do 10. Let's
Oh,
see.
it's, oh, yeah. Okay. A compact density.
Well, what are you thinking?
Hold on. I think it's reasonable to conclude.
Why? So D or E?
Yeah.
So what is more correct, D or E?
I'll say because of D.
Why is it not E?
Because the sample size was large.
Why is it not E?
What's the answer for this one though?
You're correct. It's D
Oh, okay.
because the
I
treat
think.
because the treat because selecting the sample it's basically block design, right? The stores, but the cover was the treatment.
Mm-hmm.
Okay, so the sample size actually has nothing to do with seeing is there's a difference. What the sample size actually helps you with is
So
the
if it's normal.
correct, and also it limits your what is it? Your power, right? The fact that n is higher, you have a lower chance of committing type 2 error.
Oh, if n is high.
Yeah,
Oh, yeah.
right.
Oh, that's important.
That's the importance of the sample size. But make sure that you understand that it is reasonable here because when the when they randomly assign the CD with the covers, that's
Mhm.
basically randomizing the treatment.
Mm.
Okay?
Okay.
Right. Good. Any
Yeah.
questions about that? About what about the store? Are you okay with like were you tripped out by the 70 stores part that they
Uh,
deem?
yeah, I'm good with this one.
Okay. El- 11?
Yeah, the manager of the policemen will want to compare the effect of two laundry detergent. Mm,
So at a so the way the manager works is that once 20 towels come in, he flips a coin. If it's head, he uses detergent A. If it's tails, he uses detergent B. Once he runs that on the towel, he uh, let people rate the usage of the towel, right?
mm-hmm.
From 1 to 10. How would you consider?
Think is it B?
Okay, I'm gonna ask you this question now. Explain to me why detergent A and detergent B are blocks.
Because yeah, good question. And the treatment,
Say that again.
the detergent is a treatment in this experiment.
You are correct. The detergent are treatments, but read the scenario. The manager flips a coin to determine whether A or B should be in use. Is that block?
Oh, maybe not.
No. It's block if the manager says he collects 20 towels, then he separates it into using detergent A, and he's gonna separate other towels and use detergent B. Is that what he's doing? Is he separating the towels?
No,
No, he's picking the treatment by what method?
random assign.
Correct. So is it block?
No, it
Okay,
should be randomized design.
correct.
Oh, wait, can you say that again? Like what if it's just a random block design?
Yeah, hold on. I because I wrote this down. Hold on, give me a second. AP 2012 explanation. Okay. What question was this?
11.
Okay. Are you watching the live stream?
Uh, no, let me turn it on. Yeah.
Okay. So let me read it what I wrote for the explanation. With a randomized block design, the experiment divides subjects into subgroups called blocks, such as the variety within the blocks is less than the variety between the blocks. Then, the subjects within each block are randomly assigned to the treatment. The subjects are the dirty towels, which were not divided into subgroups of detergent A and detergent B. The towel's treatment was selected randomly by a coin flip, where each detergent has an equal chance of being selected. Hence, it was a complete randomized design. Okay? So
Mm-hmm.
the first part was just the definition of the block, and the second part is me telling you like how this scenario is not a block.
So what
hmm
if we change this experiment into a block design? How can we change it?
Okay, so the subject. So here, for it to be a block, you have to divide it into detergent A and detergent B. So I could say that the manager collects the 20 towels, okay, and on Monday he will on on Monday, Wednesday, and Friday he uses detergent A. Tuesday, Thursday, and Saturday he uses detergent B.
Mm-hmm.
That would be a block because I'm splitting the towels into two categories, and I am assigning the treatment based on a block design, which in this case is the days of the week.
Okay. Uh,
I could explain it differently if that doesn't make sense.
yeah, can you explain?
So let me show you something. Hold on, block design. Psh, hold on, give me 1 second here. Um, alright, okay. Hopefully this should appear. Is it? Can you see my screen?
Yeah.
Okay. So here, right? You can be. These are your. Uh, Here, these are going to be your. Right. These are your towels. Okay. The subject is your towels. Correct.
Mm-hmm.
Okay. Then here you're gonna split into two parts. So the
Mm-hmm.
first part I can say this is your um, how
How
can you
about
split? Hmm?
like clean,
No, because they all have to be dirty, remember?
like very is like not very dirty and extremely dirty? Is it?
No, no, because no, you just want because they're all dirty towels. They all have to be dirty towels for you to see
Okay,
if the
like
detergent work.
same dirtiness.
Yeah, so you could say like if it's in like if this is like in a hotel, you can say this is part like you can split this into like the north part of the hotel, right?
Mm-hmm.
Okay. So the north part of the hotel gets that one, and if you stay at the south part of the hotel, you right, that could be one way.
Mm-hmm.
Okay, right, good. Then here,
Mm-hmm.
this can be. Then he flips the coin, right? Then the
And then
randomized.
we can
Yeah,
determine whether we will use A or B.
correct. Then the random assignment would be him flipping the coin.
Okay, so like all
So this would be uh, flip coin, right? And this would be flip coin.
mm-hmm.
But the block is just you splitting your dirty towels. He didn't split the dirty towels. That's why it wasn't block.
Mm-hmm.
He treated, he didn't separate the um, the towels. So like if it's the mouse, right? If it's seeing if this new medicine is going to help the mouse or not, right? If you just give it to all the mouses, that would be um, not block, but like separating the mouse apart. You're like, well, the first 25 is here, the other 25 is here, the other 25 is here, and the other 25 is here. Then you assign, right? That would be block design.
Okay.
Okay, good
Okay. Yeah.
or no?
Yeah, good.
Okay, all right, good. Okay. Um, 12.
Oh, 12 is C.
How did you get to C?
Uh, because randomizing is one of the way you can minimize bias.
But look at the type of biases it is. It's response bias.
Wait, response bias.
Hmm.
Would it cause any difference?
Yes, there's a difference when it's the response bias. It's sort of different because so do you know who handles like okay, response bias, is that coming from the person um creating the survey or the someone like answering the survey?
Answering the survey.
Okay. So it's from their end, right? It's not from your end that is causing that bias. Does that make sense?
Oh, then would it be B?
Mm,
I mean E.
correct.
E,
Yeah,
E,
E is correct.
E.
Because the response bias is coming from the person who's taking the survey. Therefore, you want to create a situation that whoever is taking the survey gives you the best measurement.
Mm-hmm.
Okay?
Yep.
Good?
Good.
Alright. 13. Hold on. Was there 13?
Mm-hmm. A,
How did you get A for 13?
because N is greater than 30.
I don't see how the central limit theorem works in here.
But when N is greater than 30, it satisfies condition.
Yeah, but the central limit the central limit theorem applies when n tends to infinity. The,
Oh, so what is the theory
hmm?
for N is greater than 30?
That
If
is just saying it's a the that is just a not a rule. It's like it's a baseline for it's a baseline for you to see if it's large enough to run a large sample test,
Okay.
right? It has it's somewhat related to the central limit theorem, but it's really it's like where the start. But the central limit theorem, by definition, talks about as n tends to infinity, right? Things tend to the normal. But
Mm-hmm.
keep going. It's not A.
Interesting. Uh, wait.
You think about the idea of standard deviation, right? Think about the empirical rule.
Think about the empirical rule.
Yep.
Is it B?
Why do you say B?
Like, because most of the data are within one standard deviation.
Yeah, but that doesn't tell you why it's normal.
I'm honestly, I don't know this one
Okay.
because
No, you're fine. All right, so so let me so okay, this is amazing because it's like it's rare for me to find something that you don't really understand. All right. So, one standard deviation, so you would say that the mean would be 42, right?
yeah.
Okay.
Wait,
No,
mean,
sorry, the mean is 5 pounds, right?
yeah,
So,
five.
one standard deviation, okay, we would say at one, let's see, hold on, let's see. Can you see my screen?
Yes.
Hold on. Oh, sorry. Let me see. Hold on. All right, so I wrote it here. All right. Okay. So using the empirical rule, you get a better visualization. 68, 95, 97 point, 99.7. You know
Yep.
what that is, right?
Yeah, yeah.
Okay, so at 1 standard deviation, the rabbit can weigh from 2 pounds to 8 pounds. Is that correct?
Mm-hmm.
Okay. At 2 standard deviation, it is from -1 to 11 pounds. Correct?
Mm-hmm.
But that's wrong because weight cannot be negative.
Yeah.
Therefore, the weight distribution is clustered at the lower value. Hence, the answer is
Oh
C
my
because it's
God.
skewed to the right. I can give you here.
But we
Uh-huh.
can only use empirical rule when the graph is normal.
It's you can assume it's like almost there. What?
Empirical, we can, I mean, if we want to use like the empirical rule, the graph has to be normal, right? Right?
Mm, no. The empirical rule conditions. Let me see what's the empirical rule states that for a normal distribution, nearly all the data will fall within the standard deviation. Yes, so we're basing this assuming that it's already normal.
And we find when we contradict ourselves.
Oh, here, okay, let me draw this out for you, okay? So you see the screen, right? Because
Interesting
this,
paradox.
so let me show you. This is the way I visualize it, and we'll talk about it if it doesn't make sense, right?
Yeah, yeah, I
So,
understand. Yeah, I get it.
right, the
Yeah,
fact that it's,
because we can be normal. There's like many data clustered on the left.
yeah, because the fact that it can't it can't fall within 2 standard deviation
Mm-hmm.
right here. Hold on, this should be positive. It's 2 standard deviation. So the fact that it's cut off right, where's the line? The fact that
Mm.
it's cut off right here, right? So you can say that this part is gone. How does this look like if this is the start of the graph? Do you see
Oh
that?
yeah, it's good. It's just skewed to the
Yeah,
right.
yeah, that's the rationale behind this.
Oh, okay.
Because this is where the 0 would start. But I see what you mean now. I see what you mean. You're like, well,
Mm-hmm.
the empirical rule assume it's normal, right? But I think that's the reason why they gave you this 42 rabbit,
Mm-hmm.
right? Because you can almost approximate it to be normal.
Mm.
That's why it allows you to use the
Yeah,
empirical rule.
yeah. Yeah, yeah.
Okay,
Yeah. Okay.
right? Uh, do you want to try 14? You don't need to do 14. 14 was actually excused from the test. It was
What?
weirdly 14
Uh-huh.
when it was given out. The people that graded it realized that 14 was bad, so they took it out of the test.
Oh,
So after
uh,
they gave it out.
let me try it.
No, there's no right or wrong answer. It's just worded wrong.
Oh,
So
okay.
they like that's why there was no right like yeah. If that's why when you look at the answer to it, 14 was just excused.
Okay.
Okay.
Like, is this really exist on the real test?
What do you mean?
Like,
This
does
this
this?
on in 2012 this was the official test that was given out.
Oh my God. What if the student are struggling on this question and spent so much time on
Well, that's why they say don't spend too much time on one question. Like that's
it?
why they said at the start.
Oh my God.
Does that happen? Rarely, like really rarely. Probably like
Uh,
3 standard deviation. Rare. So
yeah. Yes, three standard deviation.
it's possible, but it's 3 standard deviation
Yeah,
away. So
that's a really good comparison.
all right, 15.
Hmm.
Did I work up to 15? Okay. So let me give you some context because this question might not make sense to you. A long time ago, people used to have phones in their house, and
Mm-hmm.
no one had cell phones. and it would be called landline, right? It's the phone that is attached to the land. That's why it's called landline, and they would call that phone to get like the household information.
Oh, okay.
That's the only form of communication back there. It's using something called the home phone, right, or the landline.
Some people claim the procedure being used does not permit the result to be extended to all resistor loaders. Which of the following is not a legitimate concern about the
Kevin, you know what's the funny part? It's always the straightforward questions that trips you up. Like because I remember when it's like the mechanical questions on the FRQ, you can get it very easily. It's like these type of questions that really trip you up.
Yeah.
Don't overthink it.
Oh,
Or also put yourself in that situation. Like put
okay.
yourself in running that experiment.
Okay.
Do you understand the scenario?
Yeah.
Okay. Now, do you understand what that part of the question means is not a legitimate concern about the procedure being used? Do you know what that means?
Does that mean that so give like the reason why the procedure does not permit result to be extended to all resistor loaders?
Wait, what?
Mm,
Okay, so you're trying to poll, right? So you're trying to get a good measurement. So you're trying to get it as randomized as possible, right? And you want to make sure that the feedback that you're getting is correct, right?
yeah.
So it's
Yeah.
not skewed. Now, there are certain concerns, right, that a polling person would have, right? Let's say they only call in the morning, right? Do you see how that would be skewing the data? Right?
Mm,
Right? Like, so here they're saying, so out of all these things, which one will not skew the polling data? Does that make sense? That's what it
okay.
means, not a legitimate concern. The concern means like skewing the data.
Mm-hmm.
So which one of this is not like a factor that will skew the data?
A,
So explain
because if you're under 18, you can register for vote. Then
so
you're
is that something to be concerned about, or is that something not to be concerned about?
not to be concerned about because if you're under 18, then you're not a voter.
Okay, but who's going to pick up the phone though? At the house. Who normally picks up a phone at the house?
The call on the telephone, you mean the parents?
Well, does your parents always pick up the phone?
Sometimes I pick up the phone.
Right?
Yeah.
Are you over 18?
No.
So will the so right here if the person is not 18, no response is recorded, right? No response is recorded and then other phone and then other number is called, right? So so is that something to be concerned about?
Yeah, then it should be.
Right?
Yeah.
So A is true, right? That is something to be affected because the kid
But
might pick up the phone.
you mean a family share a phone?
Well, it's the landline. So the landline is referred to the landline is referred to as the house phone.
Where does the landline say?
Hmm?
Where's the landline?
The like people put the like home phone anywhere. Sometimes they put it in the living
Is it
room.
mentioned in
Sometimes
the
they put in.
question?
Hmm?
Is it mentioned in the
No,
question?
no. That's why I'm trying to give you some context because you're too young. I don't think that you'd understand what a landline is. Because in 2012, not everybody had cell phones. That's why. So
Okay.
people like this question. This question is weird because if you don't
Oh,
live back then, you don't understand. Like,
oh, yeah, yeah,
like,
yeah, yeah, yeah. Oh, I see, I see.
so that's why I was trying to give you some context to what
Okay.
this word. So let me just give you the end. So A is not so I wrote this. A is true because there's a chance that the kid will pick up the phone, right? So
Mm-hmm.
that will skew the data. But that's only a probability, right?
Mm-hmm.
B is the answer because the registered voter with unlisted phone numbers will not be called, correct? You're trying to get a measurement of anyone who's a registered voter, right? That's the population.
Mm-hmm.
But there are some people that can vote but do not list their phone numbers.
Can't vote.
No, can vote, registered
Can't
voters,
vote.
right? There are people that can vote who are registered voters that have unlisted phone numbers or people that don't have phones.
Mm-hmm.
Okay? That's why
Mm-hmm.
B is the answer.
But wait, so B is the answer?
Correct. Because your the population you are trying to measure is the registered voters, correct?
Yeah.
Now, there are some registered voters who do not have phone numbers, correct?
Mm-hmm.
Therefore, if you use this method, you're not going to be able, you're ignoring everyone who did not have a phone number that can vote. That's why
So
B is a concern.
yeah, it is a concern. Is it a correct concern?
Yes, it is a correct concern because
So it's not
mhm,
B.
it is B.
Wait, it is asking which of the following is not a legitimate concern.
Some people consider it's not permitted to exist, which of the following is not a legitimate concern about the process used? Yeah, B. It's the one that can affect it.
Wait, can affect it.
Yes.
What do you mean by can be affected?
So, okay, so look at C,
So
right? Registered voters
okay.
who have more than one phone number, that's less likely to happen, right? Because rarely will people have two phone numbers.
Yeah.
Okay, so that's not gonna skew that data. That's not gonna skew the data that much.
So it's
D,
C.
yeah, D. People who live in the same household vote differently. Well, that's not correct. Well, it's bec- because in theory, people who like live together or families tend to have the same political point of view, right? So they will vote the same way. Does that make sense? Like the husband and wife are both Democrat or both Republican,
Yeah.
right? So they would vote the same way. So D would be right off. So B is the only one that is not like the other ones. But I see what you mean. You're saying which one is not a legitimate concern. Yeah.
So C and D are not
No,
legitimate
no.
concern.
B is the only one. So
Legitimate is
yeah. So let
it's
okay.
reasonable, right?
So let me give. It's worded weird because some people were still questioning the expression. Let me read you the exact. Um, Let me give you a comment that one of the graders wrote for 15. Okay, it says it seems as though the individual, like this is for B. It seems as though that the individuals are not being targeted with the given sample procedure. Therefore, the company probably doesn't care to include them or anyone else that changed the sampling technique. This shouldn't be a concern for them, right? Because that's what they wrote for B, right? But
So
my
they're talking about that those voter with unlisted telephone number doesn't matter to them.
correct.
So it's not a concern.
Yes, that's why it's worded weirdly, but yes, that's why B is the answer.
Okay. But C, D, and E are legitimate
Yeah,
concerns.
C, D, and E and A are all like not legitimate. Are all legitimate concerns. Yeah.
So like registered voter who live in a household consisting one or more, it is reasonable.
Because that will not skew the data. Yeah. Does that make sense or no?
So like the husband and wife can have different political view.
Yeah, the chance of that happening is not a lot, so that's why it's not a concern.
Wait. If it's not a concern, then it's the choice.
Wait, hold on. Okay. What's your question exactly? Because I'm confused what you're saying.
B is the wrong concern.
B is a legit B is not a legitimate concern.
So it's wrong.
What do you mean by wrong?
Unreasonable.
Yes, it won't affect correct.
Right? So so D is a legitimate concern.
Register who live in the household consists more of one voter may be unpermitted. Correct. Yes, yes, ish, yes.
Yeah,
Yes,
okay.
there is a probability that the husband and wife might have different voter preferences.
Mm-hmm. Okay.
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 Again, 15's yeah, a little bit weird. All right.
Yeah, okay.
16.
Okay.
This is a device will not fail. So
Mm. D 0.922.
yep. 17.
Confidence level for proportional hotel reservation are the workers on Is this C?
How did you get? Yes. How did you get C?
Okay, so point estimate is always the midpoint of the interval.
Uh huh.
Okay, cool.
Yeah, and you just use what the n points of the intervals as your data points.
Yeah,
Okay. Yep.
midpoint. Yeah.
Yep. Okay. 18. When using one sample t procedure to construct a confidence interval for the mean of a finite population, a condition is the population size must be 10. The reason for the condition is to ensure what?
Independent. Where's independent?
What? Yeah, yeah, yeah. So what's the answer?
D, the degree of dependence.
Okay. Can you
Oh,
explain?
hold on.
You're right. It
Yeah,
is
it's
D.
D. It's D.
Okay. But can you explain that to me? What does that mean?
So that when you take the sample off from the population,
Mm-hmm.
I mean, so like when you uh like the probability will still the
The ch
probability of each sample being selected will not be affected
that
much.
much. Yeah.
Yeah.
Okay. If you see the live stream, I gave a scenario because we talked about this the first time, right?
Mm.
So when sampling without replacement, the probability must not change. For example, and we talked about this a long time ago, selecting a female class president, vice president, and secretary from an entire population. So let's pretend there are 50 females and 50 males out of, right? And the probability of getting a president that is female is 50 out of 100, right?
Mm-hmm.
Then the next chance is 49 out of 50, 49 out of 100. Notice
Mm-hmm.
that 50 out of 100 is 50% and 49 out of 100 is 49%. See how
Mm-hmm.
they're roughly close to each other? So you could
Yeah.
almost say that the probability remains constant. However, if you let the population be 10, right, 5 male, 5 female, the probability of getting a female president is 5 out of 10, which is 50%. But for the vice president, it's 4 out of 10, right, which
Yep.
is 40%. The fact
Yep.
that 40% and 50% are like way different numbers, that's why they implemented that rule of at least having 10, so that the probability, to maintain a constant probability. That's the key part. To maintain
Mm.
a constant probability, right? Without that, do you remember what type of what it becomes if the probability does change? What type of distribution it is? Let's see if
It's
you
called
remember.
binomial.
No, binomial, the probability is still constant.
Huh?
It's the special one that I taught you a long time ago. Hypergeometric.
Oh, hypergeometric. Yeah, the
Yeah.
formula. That's the giant formula.
Yeah, because the probability changes. That's why it's
Oh,
giant,
yeah.
right?
Yeah.
Okay.
Yeah.
So good. 19.
Hmm.
What does the negative 0.95 mean for the expected value? What are you thinking?
Okay. Uh, I think it's A
Why do you think it's A?
because, like, if the organization only sold one ticket, then the owner will win 50.
No, but they gave you the expected
Wait.
value already. The expected value for the net gain is negative 0.95.
Oh.
They gave you
Oh,
the expected value already.
wait. A random. Oh, yeah. I see. It's B, right?
Correct.
It's B.
Yeah, the
Oh.
negative means it's a loss. The fact that it's an expected value, you have to use on average, right? You
Yeah.
cannot say the reason why E and a lot of people say B and C are the same thing. It's not, because when it says each ticket owner will lose 0.95, that's not no, because the
It's not a
expected value,
precision.
yes, correct, right? The expected
Yeah.
value is an average value,
Oh, yeah.
right?
Yeah.
Like that's carried with the like n tends to infinity, right?
Mm.
Okay.
Mm.
All right. Good. 20. It's a power question, right?
Oh. Oh, okay. Hmm. Okay. Power.
Come on, I told you to memorize this.
I'll say is A.
Correct. And what's the what's the thing I told you to memorize to get to get the answer? The farther the what?
The further the the t-score.
So you could memorize two things. You could either memorize this, you could say the closer to the mean, the weaker the power, or you memorize the other way. The farther away from the mean, the stronger the power. You
Okay.
memorize one of them.
Okay.
Okay?
Okay. And also, it has to be in the direction of the HA, right? It can't be
Correct.
13. Yeah.
That's why it can't be larger. Yeah.
Yeah, okay. And also, you can increase power by decreasing the significance level,
Yes, because yeah. Yes. But
increasing alpha.
yeah. Again, like that was in the picture I sent you
Uh-huh.
a long time ago. Yeah.
Wait, wait. Is it increasing the significance level?
What?
So it's increasing significance level when the mean and population holds the same. So you decrease in beta and you increase in power. Yeah, yeah,
Yeah, remember like it comes from the exact picture I sent you the first time. It's the property of beta and power. Like it's right there. I think the one you're referring to is uh for fixed values. Hold on, where is
yeah.
it?
Fix n
Yeah, fixed n
and
and
fix mean.
yeah, you can adjust the beta. No, you could adjust the alpha. Yeah.
Yeah.
Okay.
And for sample size, increasing sample size will increasing power.
Yes, yes. No, no, no. It's decrease in power, and it
Uh,
decreases in power, right?
what was the question we just did?
A long time ago was which one?
I think we just said that. Where did we say that?
Was it a previous question? I don't remember.
Hold on.
Because increasing the sample size should mean you're less likely to commit a type 2 error. Therefore, you are increasing in power, right? So yes.
Yeah, so n increase, p increase.
Power, yes, yes, yes.
Yeah, yeah.
Okay.
It says as n increases, so does the power of the significance test.
Correct, because you are less likely to commit a type 2 error.
Yeah, larger
Okay.
sample size narrow the distribution of the statistics.
Yeah. I just had to say that out loud for me to hear it. Okay.
Yeah.
No, because I like again, like the way I do stats is I don't memorize it. There's a like, there's a logic to
Oh,
it.
yeah,
That's why.
yeah, yeah, sure it is.
Okay. 21, you should be able to do 21 easily. We did this last week.
Okay.
It's just which plot provides the strongest evidence that the regression line is an approximate model.
C?
Uh, Correct, right? Because no pattern.
Yeah, no pattern.
Right? 22.
A random sample of 50 students at a large school. Result in what?
So sample size of 50 students at a high school. Result, and they did a 95% confidence interval for the numbers of hours slept, and they got
Hold
that
on.
value.
Can you give me one more minute?
hmm
Mm. Oh, okay. Is it B?
How did you get B?
About 95% of all random samples of 50 students from this population would result in a 95 confidence level that cover the population mean. Yeah, because
Because that is the definition of the confidence interval.
yeah, it mentions a population mean.
Yep.
That's the reason. Yeah.
Yep. Okay. Good. 23.
Uh, a person is more likely to own a car than not own a car. False. It's not in the area. Elsewhere in the city. False. Person is more likely to own a car if sure or live in the city.
Wait, why did you say A is false?
No, I say CDER
Oh,
false.
okay.
If the person does not own a car, sure, it's more likely to. Does not own a car. Wait, I think. What's the answer for this one? I'm lost. This one shouldn't be that hard.
Yeah, well, you're just doing a lot of probabilities, a lot of conditional probabilities.
What's the answer for this one?
This one is A.
If a person
You
owns a
should always
car.
start. You should when it's like these questions, because remember the test is timed, right? So when you're looking for which one is true, you should always start with A,
Okay.
right? And just work down, because in this case they put the answer as number A. So if you actually compute A out, it's actually correct.
But
So
I don't think A is correct.
well, okay, let's do the math, right? You have a car, okay? You a person owns a car, right? The car ownership is what, 60? He or she is less likely to live anywhere else, right? So anywhere else is 15, correct? So that probability should be 15 over 60,
Yeah.
right? Now the next one, the one that owns a car, which is still 60. Now this one is downtown. Downtown is 10, right?
Yeah.
So 10 out of 60. So if a person owns a car, he or she is more likely to live in the city than to live in
Wait.
anywhere else.
Oh, which
That
one
means
is true? Oh my.
correct.
I
Did you just not read it correctly?
I don't know what my brand was doing.
15 out of 60 is greater than 10 out of 60.
Oh
So,
my god. I thought when I do A, I thought which statement is false. When I do B, C, D, E, and I thought which statement is true.
Yeah, that's why I was asking you, like, why is it false? Like, the
Yeah.
question was asking for true. I can't help you there, dude.
Oh yeah, why is it
Uh,
false? It is true, so it's the answer.
okay, I can't help you there.
Oh
Alright.
no.
There's not a lot of teaching going on there. Okay, 24.
It's just something about double negative. Uh,
What's up,
Tell me when you got the answer.
uh, okay. Is it D?
Okay. Why do you say it's D?
Because
Why is it not A, B, or C? Like, what's wrong with the
it can
100?
be it can be 100. It's not a proportion.
Alright, good. Then what's the difference between D and E?
We use the interval instead of T interval because it's about probability.
No, no, what's the difference between D and E in terms of the answer? 1.96 and 1.645, right?
Yeah, 1.96 is from the Z table, and
Sure,
645 is from T table.
sure. What? It's normal though.
Oh, it is normal, but
Yeah, so,
do you know
you,
when we use T or Z?
well, this is 432. That's large, so Z. T is only
No,
for small.
no, no, because my teacher told us like she asked the AP grader,
Uh huh.
and they told her that uh you use T test and T interval when you do not know the parameter of the population. I mean, when you do not know when you do not know the standard deviation of the population.
When you don't know the what?
Standard deviation of the population.
Population.
Yeah. When
Uh,
you use Z when you're dealing with probability and you know the standard deviation of the population
well, all I know is that this says 95% confidence, right? So that is how many standard deviation away?
is 1.96.
Two
Two.
standard deviation away.
Yeah. Yeah.
Empirical rule, two standard deviation is 1.96.
Yeah.
That's how I get it. But
Mhm.
I let me hold on.
Even though they only have like 10 people and 3 are in favor, or they have 30 people and 10 are in favor, we still use Z because it's about probability.
Yeah, I'm going with the 432. But okay, yep.
Yep. Anyway.
25.
The communicating time for students is normally distributed with 30 minutes. Is it A?
Correct. Oof. Yep. And how did you do that? Did
You
you do?
find the you find the probability uh when the Z score is greater than 1?
So you didn't do the empirical?
Oh, yeah.
25, I did the empirical.
Oh, yeah.
Because 35 minute is only one standard deviation away.
Oh, yeah. 66. Oh, makes sense. Makes sense.
No, like I don't know, like to me that like I always try to figure it out using the empirical rule before I have to
Oh,
like use the chart. That's
yeah.
why.
It's faster.
So,
Yeah.
26. When you have questions like this, just look at like which one wouldn't make sense and cross those out and just look at the difference between the answers. Does that make sense?
Mm.
Yeah. Because you should already knock off what two answers.
A and B.
Yeah, because of the 1.96. Yeah.
Yeah. I'll say is D.
Why is it not E? Why is it not less than or equal to 0.05?
Margin of error is not 5%.
Yep, that's it. That's the difference.
Yeah.
Okay, good. 27. A manufacturer claim A is less longer than B brand. 9 batteries of each type are tested independently, and the hours analyzed are shown. Private the assumptions for inference meet the test can be conducted to determine if brand. Huh, that's still interesting what you said about the. Huh. Because by definition T and Z are just separated by size.
It's a t-test and it's one side and it's two samples, so it's B. Wait.
Uh,
Oh, it can be paired.
no, you're correct. It's B. It's not paired.
It's B.
It's not paired
Th-
because the battery are tested independently.
Oh, like what do you mean, test it
No, they
independently?
say it right here. 9 batteries each are tested independently. Once you say test independently, it's not paired.
Okay. Then what is an example of like a paired t-test?
Paired t-test. Um, um, oh, let's say okay. Like, do you know a keyboard? Like, okay. Oh, like, you know the old Game Boys? You have to put batteries in them,
Mm-hmm.
right? And you know how they're like 4 battery slots.
Mm-hmm.
Let's say you use 2 from brand A and 2 from brand B. That would be paired. Does that make sense or no?
Uh,
So your device that you're testing on requires you to use 4 batteries, right? You grab 2 from brand A and 2 from brand B. That would be paired. They're together. But if you're just using just brand A, right, then
mm,
you're using like a different device, then you use brand B, that's when you're testing it independently. They're not powering the same object. Does that make sense?
oh, or like okay. Like if we want to type, if we want to test the effectiveness of the diet, we can use pair test because we can compare the weight after diet and weight before diet.
Yes, that could work.
Oh, okay.
Okay?
Like compared to itself, right?
Yes.
Okay, makes sense. All right.
28.
Two-dimensional hypothesis. it has to be two value, right?
Correct.
Is it E?
How did you get E? You just doubled it?
Because there's no relationship between 0.78 and 0.44.
The answer is D.
Is
Because if
D.
it's
Okay.
if it's one tail, it's the 0.22. But if it's
Wait. Why is the one tail 0.22?
conducted a p-value of 0.44, the experiment has conducted on one tail. Which of the following is true for the p-value conducted? The possible, the because the possible. Hold on. So if it's two tail, right, it would be 0.2 on both ends, correct?
If it's two tail 0.2
Yeah.
on
Right.
both ends,
Uh huh.
2 on both ends.
Yep.
Okay.
But if it's not, if it's one tail, it either has to be less than 0.22
Oh, so P.
or greater than 0.78
Well,
because
but P value can only locate on one side. Can P value locate on both sides?
yeah, because the p-value just determines basically it can be like shaded to the right or shaded to the left. P-value
Okay.
is just a probability value,
Okay.
right? Here, I have a good picture to show you if you want to
Okay.
see it. Hold on.
Yes.
Mm, See it? Do you see it?
Not yet. Oh, yeah.
Uh,
Oh, it's. Mm-hmm.
Good?
Mm-hmm.
Right? So that's why it's D. Because it makes no sense for it to be 0.22 and 0.88 because that would be more than 100. No, that would be more than 1. So the probability would be off.
Hmm. Can you
Okay?
show that picture again?
Yeah. So the one tail, it's either 0.22, right, to the right, or 0.78, right?
0.7.
Because it
Oh.
has to be 100, right? Together, it has to be 100. Or 1, basically.
Oh.
Because the p-value is probability, right? 1 or 100%.
Okay.
Okay?
Okay.
Good. 29. Do you know what type of test this is?
Uh, two sample t-test.
Yeah. You have to get the p-value.
Mm-hmm. I got D.
D is correct. Yep. What was your p-value?
My p-value is between 0.01 and 0.02.
Oh, yep. Okay. Yep. Because when I calculated, it was 0.016.
Yeah.
Okay. Yep. That's it. I mean, you can do the rest. We could talk about the rest later. But
Okay.
it only goes up to 40 questions. So.
Actually, can we do 30? Like,
Yeah.
it's just what question I really want to do.
Okay. Yeah. Go ahead. We could try it.
The relationship between vehicle type and color.
They give you a sample size of 275, so that should already tell you.
Yeah.
Is investigating the type of and the color of vehicles each person.
Chi-square good of hold on. I think it's independence. Chi-square test of independence.
Why is it not goodness of fit?
Because wait,
Why are you saying it's independence?
if it's goodness of fit, it is like P1 equals to P2 equals to P3.
Yeah, the probability of the proportion of each is different, right? Yeah.
Yeah.
Good. Yeah, you're correct.
Is it independence?
Yes.
Oh god.
No,
Yeah.
that's the correct way to justify the answer, because it's not the proportion, and you can't really calculate like an expected value to even do goodness of fit.
Okay.
Yep,
So what's the answer?
it's E. You're correct. It's
It's E.
independence.
Okay.
Yep.
But what can we use to sample t-test?
Why you can't do a two sample t-test? First of all, it's 275. It wouldn't be a t-test. It's too big. Uh,
Is it too big?
yeah, 275. Like that's above the t-test.
Is there a limit?
Yeah, the t-test is only for something that's small.
Okay.
Right? A z-test is something for the large. So are you gonna ask me why you can't do a two sample z-test?
Uh-huh.
Why can't? That's a good question. So each person is randomly selected from the company. Mailing list is classified according blah blah, and the vehicle he or she drove, the data is provided. Which of the following
Okay.
process would be a news? Oh, right here. Used to investigate whether there is a relationship. The two sample test does not test a relationship.
Okay.
It could test like which one's better, but it can't test like relationships.
Mm-hmm.
It's just the wording of the question.
Oh, I see. I mean, if you want to use the t-test, you have to use it like so many times.
Yeah, t-test is you know the difference
Oh,
between the t and
if
z-test
you
is the
want to use the t
population,
t-test.
right? Your sample size. That's the difference between the t-test and the z-test.
Yeah.
Right?
Okay, I get it.
Yeah.
Okay.
Okay?
Because if you want to use a two-sample test, you have to use it like 5 times here.
Wait, what? No. No. Two sample z-test and
Two-sample z-test, yeah, because like the proportion is h naught is 0.5 and do you understand?
no, I don't understand what you're saying. Like my justification for the
Okay,
reason why it's
okay.
not a two.
If I want to set up, for example, if I want to set up for the red case, I want h naught equals to h naught is p probability of a car is red minus probability of a truck is red equals to 0,
Okay.
and ha is not 0.
Okay. But what are you trying to prove there? You're trying to prove that it
The
is.
probability for the type of car should be the same.
Yeah, okay, yes. In that
Yeah.
context, yes. But the reason why in 30 is because they're doing it because they're trying to see if there is a relationship. That's the key word.
Yeah,
So,
relationship.
yep. That's it.
Okay, thank you very
Okay.
much.
All right. I will see you next week. Okay? Are you
Okay.
taking any other tests before then?
Yeah, I unfortunately I only have one, so
You're not taking the computer science one?
oh wait, what do you mean?
This is AP
Like the
test taking. Yeah. Are you taking any
AP
other
exam
tests?
or AP?
Exam, yeah. Are you taking any other AP exams?
Next week.
Yeah, which ones?
I only have A push next week.
Okay, yeah, so focus on that first before you
Uh-huh.
start worrying about the stats, okay?
Okay.
Alright?
Yes, that's actually stats is my very last one.
Yeah, 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 so worry about that one last, okay?
Okay, okay. Thank you very
Alright,
much, Brent.
alright, see you next week. Bye.
All right. See you next week. See you.